Okay, so in part 3, this is the final piece, we're going to talk about the implementation of the GCD concurrent app, just to give you a flavor of how to put all the pieces together. And then if we have time, I'll quickly summarize the pros and cons of a couple of different Java thread programming models. So you recall the GCD app, which is visualized here, goes ahead and basically computes the greatest common divisor of two numbers. You probably remember from your math classes in probably 6th grade or something. That's the largest integer that divides two integers without a remainder. And here's what we're going to do. We're going to have a bunch of classes involved. You can get the code here. We're going to have this thing called the lifecycle logging activity. That's just there to make it easier to tell what Android's doing with respect to its hook methods that it calls back when pieces of code start to run. We won't worry about that right now. The driver program here is called main activity. Whenever you see the word activity, it probably means it's an Android thing, because activities are the primary user-facing classes that Android provides. And then we're going to have two different implementations of our logic. One is going to be called GCD thread, and it's going to extend the thread class, the thread superclass. And the other is the GCD Runnable, and that's going to implement the Runnable interface. So those will be the two primary ways we're going to do this. And so if you go and take a look at the source code for the GCD app, you'll get a chance to see the different approaches for that. And I won't go through that in detail, but I think we kind of talked about that earlier. If you go back and look at the earlier video, I showed you one way is to implement, this is from last time, the GCD Runnable. You implement that, and then you start a thread, and you give the Runnable as a parameter to the thread, as its constructor's parameter. And then the other approach was to subclass from the thread class. And then when you start that thread, it'll start to run the runHook method. Okay, so let's talk about the pros and cons, and this will also kind of give us a flavor of some of the things. Here is the extension model. So here's the version where we extend threads. You can see GCD thread extends thread. Remember, extends is just the Java way of inheriting stuff. If you're in C++, that would have a different syntax, but it's more or less the same semantics, more or less. And as you can see here, we go ahead and have the run method that does the work. We have the run method is going to call the compute GCD method, and we set some things in this set method. The good news is it's very straightforward to extend the thread class. So you say GCD thread extends thread, and then you simply consolidate everything in one place. So we have our activity here, which is what we use to keep track of the user interface stuff. We need to talk back to Android. And we'll talk about this later when we talk more about what Android does. But when you start to change your phone, like if you have an Android phone and you have it in portrait mode and you rotate it to landscape mode, then special things happen. And you'll actually see that if you run the Palantir simulator application, either on your phone or with your emulator, you can rotate the screen, and it does it all in a really cool, consistent way. So putting everything in the thread makes it easier, and we'll talk about this when we get into managing life cycles with Android. There are some downsides, however, with extending thread. And one of the problems is you have to extend the thread superclass. And one of the weird quirks of Java, which is not the same quirk that C++ has, is that you can only extend a single class. So in Java, you can only extend one superclass where they don't support multiple inheritance. They support multiple interfaces for a class, but not multiple inheritance of superclasses. So at this point, you've kind of blown your dependency on the thread superclass. And you can read more about this and sort of learn why that's the case. I won't go into the details of it unless you're really curious. The pros of implementing Runnable are much like the cons. They're sort of the inverse of the cons of using extending thread. So one of the things you can do here is you can see that this model has a GCD Runnable class which implements Runnable and implements serializable and extends random, just for kicks. So we actually don't subclass from thread. Instead, we implement Runnable. And you can see also we can implement a whole bunch of things. We don't have to limit ourselves to one. So a subclass can implement multiple interfaces. And I just do extends random just to show you I could do it. I don't actually have to do that. I could always have a random object that I pass into the constructor or something. And therefore, we can have different extension. So implementation is more flexible in Java because you can have multiple implementations within a class of interfaces. Runnables are also more flexible because you can reuse them in other contexts. So if we go ahead and have our GCD runnable, then one way to do it would be to spawn a thread passing that runnable in as the constructor parameter to the new thread. But another way to do it would be what I show here. So in this case, we make ourselves a GCD runnable. It's just a runnable. We create ourselves a new fixed size thread pool. We'll talk a lot more about thread pools down the road. And then we go ahead and we execute that runnable in a thread in the thread pool. So without having to do any other changes to our GCD runnable class implementation, we were able to execute it in a different context. So now it's going to be running in a thread pool as opposed to running in a single thread, which is what would have happened had we extended from thread. So it's more flexible. There are some downsides, however, to using runnables. And we'll see those here. This, by the way, would be the kind of simple way of doing it. We would say GCD runnable, runnable command, new GCD runnable, make a new thread with that as the parameter to the constructor for thread, and then we would go ahead and start this thread. So that's the other way to do it instead of using the thread pool. There's more moving parts. So as you can see here, we have the runnable, we have the thread. So the runnable and the thread are actually two separate things. Whereas if we're doing extending from the thread class, there's just one thing, and state is in one place. And therefore, the runnable and the thread have to be managed and accessed separately, because we got two of them now, not one of them. And that becomes a bigger deal if you need to keep track of the thread and its state in a single object. And you would normally need to do that if you had to deal with thread lifecycle issues that might arise depending on how you're going to handle things like screen rotation in Android. There are other ways around this, of course. In practice, it's often the case, not always, but often the case, that Java software is software written either for Java class libraries, the internal parts, or people writing Java applications, or Android software, the infrastructure part, or Android applications written by end-user developers, app developers. We very commonly implement runnable rather than extend thread. It's less common to do this. You could do it, but you have to think about why you would do it, whereas it's much more common to do runnables. And as I mentioned before, as we start getting into the brave new world of Java 8, which has actually been around for 5 years now, so it's not so new anymore, but it's still less common than it probably should be, because people are often reluctant to embrace cool new stuff than they should be. Lambda expressions are becoming very popular, and so they simplify a lot of programming, and you can end up doing things with less code, less work, less effort. Okay, so that is the end of that one.